transfer learning, and deep neural networks for character and object recognition. In this project, I, Lane Mott, sole proprietor of this presentation and report, was tasked with creating an artificial neural network to recognize and categorize different articles of clothing into basic subcategories in order to distinguish what garments their customers were wearing on a day-to-day basis. This allows the client to supply inventory to future customers with in-demand products that they consciously or subconsciously are in the market for. This neural network was trained using a train GDX backpropagation technique, 3 hidden layer sizes ranging from 112 neurons, 56 neurons, and 28 neurons respectively at 60,000 samples with a division ratio of 15% training, 15% validation, and 70% testing. We also used a receiver operating classification curve and a performance plot in order to gauge the accuracy and efficiency of these neural networks. The background of the MNIST and Fashion MNIST are as follows. The MNIST was created from the Census Bureau and used a 28 by 28 matrix of handwritten numbers. These images are low quality and do not do more than to train a system to distinguish handwritten numbers of various styles. A Fashion MNIST does much of the same, however, it uses several different articles of clothing, all categorized under 10 classes. These are still a normalized 28 by 28 matrix. There's just happened to be more going on inside of each picture. The methodology for training this neural network was, as previously stated, we used a train GDX backpropagation at 60,000 samples and 3 hidden layers at 112, 56, and 28 neurons, respectively, per hidden layer. The division ratio was set at 15% training, 15% validation, and 70% testing. We put it at 70% testing because this is a more realistic approach to how a neural network should operate. It would gain more knowledge, or it would test its knowledge more, based on its little that it's been trained already. This allows the system to divvy more time towards showing what it knows rather than validating what it has already been taught. Here you can see we have a basic understanding of the model of our best performing network and its different branches of weights. Each color category is a subsequent different weight, and the closer it gets toward the output, the heavier the weight would be. This is also easier for backpropagation as once we hit the blue side of weights, we are so far from our output that our error is deemed less accurate. So as our results, the best neural network has the highest true positive rate, which is represented in this curve here, as we can see. It is the closest to a 90-degree angle in the top left corner, which would mean it has a 100% true positive rate over time in all 10 classes. As you can see, class 6 has the lowest true positive or highest false positive out of all iterations that we run, and this was the same across all different versions. We were able to see that trends headed towards higher performing networks with smaller hidden layer sizes. However, our highest performing network actually had the most hidden layers. This was not the same for some of my colleagues, however, I found it to be my best performing network in my case. As said previously, running train LM backpropagation hardlocked several systems after several different attempts from me and my colleagues. So in conclusion, our best performing networks were large, however, the hidden layer sizes were small. This is not common for a generic perceptron, which usually runs with one hidden layer size, and that one hidden layer size is usually larger than most. All versions, however, ran mostly identical with very minute changes in between different classes. Train OSS was also another high-performing neural network, but I believed that Train GDX performed at a higher standard. With a deeper focus on learning rates, I'm sure the performance could have increased. However, my understanding of the MATLAB code, I was not able to adjust the learning rate effectively. I, in my misunderstanding, thought the backpropagation techniques such as train LM, train OSS, train GDX, and train RP were adjusting the learning rate. However, I was wrong after doing a little bit more research. Thank you for your time, and thank you also for a great semester.